Why, hello there. All right, it's been long enough. Let's get into what we've been really waiting for. Just a moment ago, the systems had finished with its analysis of the crystal samples, and it brought both results that were expected as well as intriguing. First off of composition. As expected, the various crystals were indeed each a type of silicate. However, the different structures found were something I had never seen exactly before. The small crystals around the main tunnel were simple peroxides. However, the spire and the behemoths in the lower cavern were, goodness gracious, the sheer variety of crystal lattice formations in just a sliver of crystal sample was simply astonishing. Nesosilicates, cyclosilicates, innosilicates, sorosilicates, each with their own individual cohort of trace elements from beryllium to hafnium, and a slew of cations in between. Not only that, but the sheer variety of different interlocking structures was beyond count. The additions resulted in a number of highly specific crystalline amalgam structures, which appeared to result on the macro scale as a variety of intricately unique protrusions, aka are massive crystals. With this, we have what is necessary, I believe, to explain our question of efficient crystal organization, at least in part. The copious different trace metals and other elements that could be found throughout the structures had been bothering me. At various points, the distribution seemed just too random, like... It's just a bunch of random crystal samples. Look at me, just trying to find the fantastical out of what is likely just some majestic coincidence of nature. Always a good reminder to keep your work at a distance now. That's a lesson to all of you fledgling scientists out there. Always in your work try to separate out what you want to see from what is really there. Now, back to some proper scientific analysis. I'd say, as mentioned before, that the specified patterns of crystal aggregate arrangements are what allow for the more efficient and sturdy crystal growths down below. The active molten rock deeper down would be what consistently brings new material, a good soup of all sorts of trace elements, including, of course, copious amounts of silicon. There would probably be enough unevenness and irregularity in the flows to allow time for different structures to develop together, hence the many potential silicate types. Those that could grow and interlock together and maintain structural stability despite the heat could remain and further develop, while those that could not would simply dissolve back in the next rise of molten rock. What is amazingly neat about this is that such a process could potentially allow for a sort of natural selection that would favor more organized crystal patterns. Certain higher organized crystal networks would be favored due to their higher potential heat resistance, and thus, there we go, giant complicatedly interlocking crystals. Sure, there are some holes in this hypothesis, such as why these crystals will then still show such specific and orderly organization above the molten rock flow level. But then again, this is just merely the beginning of this planetary study. In time, I'm sure more will be revealed through more thorough research. One last bit of evidence for the natural selection hypothesis. The organization and composition of the crystals appear to differ between the spire above ground and its brethren below. If my hypothesis is correct, then this is because the higher-up parts of the crystals are of an older generation of crystal networks. On my next expedition down, I should expect to see a similar change in structure and composition as I analyze each lower part of the crystalline protrusions. That'll be fun to look for. Speaking of the future expedition, I'll be bringing along some more analyzing equipment, as I try to get as much data as possible per expedition. Good Lord, will carrying around the extra weight be a nuisance? But, hey, as always, it's for the attainment of further scientific knowledge, so how can I really complain? It's not like there's anyone else to carry it anyway. I'm thinking I'll bring the multispectrum light wave analyzer, which should help with detection of distinct structural differences in the crystals. And this is the most important part, even when at a distance. A pocket vibration analyzer as well ought to help, as to give a heads up for rising molten activity, giving sufficient time for me to make my escape if need be. I hope. Well, I guess I should probably also bring some heat protection gear as well, don't want the equipment to just fry as soon as I get down there. Now the task at hand will be to adapt the heat protection gear to my equipment, which were not necessarily made to go into hot pressurized caves. That'll probably be a good bit of the rest of my day, attaching the protective foiling just right. But once that's done, it'll just be a matter of waiting for the sun to dip down just enough, which should be early tomorrow. So, with that, I should have about everything together for expedition number 3. That's about all I have today. The crystal structures, compositions, and combinations should all be found in my notes in the log. As always, it is a pleasure to report to you, my fellow workers in science, and I wish you all best of luck in your pursuits. I will return in a day or two if all goes right. Until then. End of log 1, day 6.